Welcome to lecture 26 on risk management and insurance. In this lecture, we will do a case study on drought insurance. Hail insurance is very old. You can insure against hail since the early 19th century, so hail insurance is about 200 years old. But drought insurance, even today, does not exist. When you have drought insurance, then it's always strongly subsidized by the government. For example, in the United States, they have a well-established system of drought insurance, but the government subsidizes it very heavily. So we have private hail insurance since more than 200 years, but the private drought insurance basically does not exist. Now, what explains this market failure? Now, hail insurance, hail is a regional event, whereas a drought may affect an entire country, or even in Australia, an entire continent. Therefore, the weak law of large number does not apply to drought insurance. By selling more and more insurance contracts, the insurance company cannot spread the risk because the entire country may be affected by drought. With hail, when the company sells more and more contracts, so maybe in some regions we have hail losses, but in other regions we don't have it. And so here, the weak law of large numbers applies. So with drought insurance, which may affect the entire country or even an entire continent, an increase in the number of insurance contracts does not reduce insurers' risk. Remember, we have discussed those terms in an earlier chapter. Now, asymmetric information is also more prevalent in drought insurance than hail insurance. Farmers cannot influence hail losses. In some countries, actually, they shoot rockets into clouds and then they spread some chemicals in the hopes that there will be no hail, but it does not work well. So basically, hail cannot be influenced, but losses from drought depend very much on farm behavior. They depend on farm management practices. And those farm management practices, the insurance companies find difficult to observe. So we have here high monitoring costs. So with drought insurance, we have adverse selection and moral hazard, because really drought losses depend on farm management. With hail insurance, that's it may hit you or it may not hit you. It does not depend much on farm behavior. And so here there is no adverse selection or less adverse selection and moral hazard. Now, looking here at drought insurance, you see the insurance company does not know whether the farmer is willing to follow the following management practices that reduce drought damage. So the farmer has to decide on the crop and on the variety of crop, and different crops and different varieties of those crops maybe more or less drought resistance. So the question is, does the farmer really plant the suitable crops? So the farmer should observe the optimal flowering window. Plants are usually most easily damaged when they are flowering. And so the flowering should take place in those months of the year where you have the most suitable climate. So the farmer should look ahead when planting the crop. It may flower 2 months later, or 3 months later after planting, and the crop should be planted. So we really have the optimal flowering window in the best, in the most suitable months. Again, a farmer may be more or less careless here and okay, not observe the optimal flowering window. Now, a prudent farmer also may stagger the flowering windows. So if you have a larger farm with different paddocks, with different plots of land, then maybe you plant in one paddock, and then a week later you plant in the next paddock, and again a week later you plant another one. And so the flowering then takes place over 3 weeks or over a longer time period, and that naturally spreads the risks. If you have adverse weather events, then maybe one paddock will be destroyed, but you still have the other 2. So the optimal plant density is also very important. A very densely planted field, you have a lot of evaporation to the leaves, because there are a lot of leaves when you have a lot of plants, a lot of densely planted plants. So if you have a drought, you may be in trouble, because a lot of evaporation, so you lose a lot of water. So during a drought, a less densely planted field may be preferred, maybe better. So again, a prudent farmer maybe has less densely planted fields. Farmers that is somewhat careless plants the field more densely, and then hopes, okay, naturally for a bigger crop. Then the residual soil moisture, that's so soil moisture that's from the last year. With wheat, so wheat roots are surprisingly long. So wheat is not just a grass, okay? So wheat with 20-30 centimeter of roots. So wheat roots go down 1 to 2 meters. That's why wheat is so tough and really also grows in arid climates with not a lot of rain. So the roots may reach down 1.5 meters, maybe up to 2 meters, and really use this residual soil moisture far down, which is there from the last year. So when last year it rained a lot, then you have a lot of residual soil moisture, and then this year you can take higher risks. But if last year you already had a drought, then this year you have to be more careful. And again, the question is, does the farmer consider that when making the planting decision? Some naturally soil types, microclimates, okay, may matter. Typically, in lower lying regions of the land, you have more frost. This causes cold air sinks down. So also here, this should be considered. And then weather forecasts should be considered, and so on. So the insurance company does not know to what degree a farmer is able and willing to follow best farm management practices. And so the insurance company has monitoring costs. And the insurance company would like to distinguish between the risky farmer and the less risky farmers. So we have here adverse selection and moral hazard. And this causes costs. On top of it, with drought insurance, we said the weak law of large numbers does not apply because an entire country may be affected. And so if you sell more and more insurance contracts, the risks are correlated. They are not independent. And so the weak law of large numbers does not apply. With hail insurance, if you sell more contracts, then maybe on some farms there was hail, on other farms there was no hails. So here the risks are unrelated, they are independent, and so here the weak law of large numbers actually applies. This may explain why we have hail insurance actually now for more than 200 years. It's easy to buy hail insurance for farmers, but it's not easy to buy drought insurance. Drought insurance, private drought insurance, essentially does not exist. Now here's a new type of insurance, index insurance, that takes care of those problems. It's actually just quite a new development that has over the past 10 to 20 years. Now, underwriting costs, which are caused by adverse selection, we have to distinguish between the high and the low risk farms, and the monitoring costs, that's a moral hazard. We really have to monitor versus a farmer does really uses best management practices. Those costs do not depend much on farm size. You see, if you have to monitor a farm, maybe you sell insurance in Cape Town, and then the farm is 500 kilometers away, somewhere in the countryside, in a remote region, and you have to monitor that farm. Then the insurance company has to send out a person really to look at that farm. Now, versus that farm is big or small, then the costs are the same of traveling out there. So you have those transportation costs, maybe you even have to take the airplane, and so you have those costs. Now, for a larger farm, it naturally may be worthwhile really to have those costs, to incur those costs, because a large farm will pay more premium income to the insurance company. For a small farm, it will not be worthwhile to send somebody out 500 kilometers into the countryside. The costs are too high. So these costs are bigger impediment to private provision of drought insurance if a farm is small. Now, index insurance now provides a new type of insurance that is also actually accessible to smallholders, to small farms. And I would like now to explain this new type of index insurance. Now, in traditional insurance, which covers losses, loss indemnifying insurance, that covers the actual losses. And so the insurance company should distinguish between high and low risk farms. So because of adverse selection. And it has to monitor the farms because of moral hazard. And so it has high monitoring costs, it has high underwriting costs. So, and then when there is a loss, they have to send somebody out and really estimate that loss. So we have a high loss assessment cost. That's also expensive. With weather index insurance, we get rid of most of those costs. Here you have a local weather station and also satellites, and they measure the weather during the growing season. And they actually, we compile a kind of an index, which the numbers indicate was the weather favorable or was the weather bad for the crop. Now, to calculate that index is naturally not easy. The weather station will measure, okay, what was the temperature, how much did it rain, and so on. And then it adds up those things, it combines those data into an index, and the index shows whether it was a good season for the crop or whether it was a bad season for the crop, maybe so bad that even it was likely that the crop was destroyed. So the insurance payment, the insurance payouts are the same for all farmers. The same payment per acre. It's just simply based on the readings of the weather station. So we don't have adverse selection and moral hazard. Every farmer gets the same amount of money per acre of crop. And in the end, we don't have to do a loss assessment. The payment is just based on the readings of the weather station and this index that combines different dimensions of the readings, like temperature and rain and so on. So two types of insurance: traditional loss indemnifying insurance, it covers a loss, But here it depends. If we want to cover the actual loss, then the insurance companies would like to distinguish between risky and not risky farms, and they have to monitor the behavior of farms. And in the end, they have to measure the loss. They have to estimate the loss. They have to send somebody out. With weather index insurance, the insurance payout is just based on the readings of a local weather station, maybe also on measurements from satellites. Those readings are combined into an index, and if the index indicates that it's likely that there was a drought and the crop is destroyed, then every farmer gets the same payout per acre. So there is no loss assessment. So we don't have adverse selection. We don't have moral hazard. The behavior of the farmers does not matter. We don't have loss assessment. Okay, yeah, here you see one of those weather stations. That is very well developed actually in Kenya. Kenya is somewhat of a leader in index insurance. So if you have a drought and the crop is damaged or even destroyed, then every farmer gets the same payout. If you have a flood, the crop is destroyed, then every farmer gets the same payout. It's based on the readings of the weather station. So this index insurance eliminates most information costs associated with traditional loss identifying insurance. There is no adverse selection because insurance payouts are independent of individual farm risks. The insurance company does not have to distinguish between risky and not risky insurance buyers. There is no moral hazard because farmers cannot influence the payouts. If a farmer manages a farm badly, he gets the same payout as a farmer that manages the farm well. So all those costs actually do not exist. Actually, risky farmers are underpaid here. You see, there is an incentive to manage your farm well, because everybody gets the same payout. And if you manage your farm well, maybe then your loss, your crop loss is lower than the one on others farms. So you have here an incentive to manage your farm well. So it creates actually beneficial selection, not adverse selection. But index insurance gives rise to a new type of risk. It's called the basis risk. So basis risk, in finance, basis risk is a residual risk associated with an imperfect hedge. We use insurance to hedge our risks. We can also do hedging with I've seen with options and with forward contracts or with short selling. But here we use now insurance for hedging our risk. And the hedge may not be perfect. That's what we call the basis risk. In index insurance, or it is in insurance, it's a risk that the payout does not match the loss suffered by the insurance buyer. Basis risk exists in all types of insurance, but is particularly important in index insurance. In index insurance, basis risk is high if you have a low correlation between crop damage and the readings of the weather index that determines the insurance payout. Basically, if you have a bad weather index, an unreliable weather index, then you have big basis risk. So maybe you have a drought, crops are destroyed, but the weather index does not show it, then the farms did not get paid. So we have this basis risk. The hedge does not work. So a farmer may be underpaid or overpaid if the insurance payout depends on the readings of a weather station on this weather index that we calculate, and if it does not depend on the actual farm loss. So here it's really the quality of the weather index that we calculate from the readings of the weather stations, which determines that the insurance payouts. The quality of that index is very important. And there is an intense research effort here, okay, to develop good indexes for different types of crops and for different locations that minimize this basis risk. You just do not have one index. You must actually develop indexes for different types of crops and naturally for different geographical locations. So that's here there is a huge research effort going on, and Kenya is actually somewhat of a leader in that field. Now here, the demand for weather index insurance. I'm telling you something second order dominance on stochastic dominance. Now I have shifted that chapter to the end of this course, so I really cannot really discuss this slide here. The implication of the slide is that a risk-averse individual may then prefer to buy no insurance, even if the insurance premium is actuarially fair. That can happen with index insurance, and that's naturally a worry. So even if the insurance premium is fair, the person as a farmer then prefers not to buy insurance. Naturally, on top of that, insurance premium will not be fair, so because of administration costs. That's another reason that the demand for insurance, for index insurance, is small. But we have to return to this slide later on when we have discussed stochastic dominance. We do it in the last chapter of this course. So the low administration costs of index insurance make it possible to insure even very small farms whose premium payments naturally are small. We don't have to send out people to measure losses. We don't have to distinguish between the risky farms and not risky farms. Just everybody gets the same amount of money. So we save all those administration costs. So it's now also worthwhile to insure very small farms that naturally make small premium payments. The farm actually can be as small as 1 acre, 1 or 2 acres. I have read both. Okay, so, but even a 2-acre farm is naturally a small farm. So crop failures and loss of livestock lead to famines and dislocations of populations, rural populations in Africa. If this weather index insurance is successful, then this will enhance food security and welfare in rural sub-Saharan Africa. It's a new development over the past 15 years, and in this field there is a lot of research now going on. So that's an actual research topic that you may be interested in. Now, this reading here, I wrote an article here, and I put it on SSRN. You can read the article. It's not an academic article. It's more like a newspaper article explaining weather index insurance. And then also here, I'm quoting quite a lot of sources of very recent sources that you then could go and also read. So it's a working paper. It's more like a newspaper article. I wouldn't call it an academic article. Let's shortly look here, so you can click on that. No, it does not work here through Zoom. But you have here, copy paste this out into your web browser, and then you will find the article. Okay, a very new development, weather index insurance. It may resolve the problem that drought insurance, the private markets do not supply drought insurance. And naturally in Africa, we really need drought insurance. We have a lot of arid regions. So we would like to have drought insurance. And maybe weather index insurance is one way to go. Hail insurance is no problem. You can quite easily buy insurance against hail. But drought insurance is really a problem. In some countries, we said, okay, it's just provided by the government, as it's United States, it's heavily subsidized, but not in African countries. So that's an interesting topic here that you may wish to look into. So that's for today. Thank you very much.